Hi again. So now we're going to actually calculate a Bootstrap confidence interval, and we're sticking with the 95% confidence level at first, but we will get to vary that in this module. So you might see these familiar formulas: point estimate plus or minus the margin of error. That's not changing. And our point estimate could be p hat or x bar plus or minus 2 standard errors. And remember, that corresponds with the 95% confidence level. Okay, so remember, we're only going to take one sample though. So we use the point estimate from our original sample, and we're going to call that one sample our original sample because that's how they listed on the applet. And then we're going to estimate, we're going to use our estimate of the standard error from our Bootstrap distribution. Okay, so remember, the idea here is the sample-to-sample variation in the Bootstrap distribution is very close to the sample-to-sample variation in the population. Okay, that's what we're going with. So here's an example. Find a 95% Bootstrap confidence interval for the mean price of a Ford Mustang. Okay, so we're going to go into Stat Key. We're going to choose the Bootstrap. Well, I have the direct link for you, but if you're getting there from Stat Key, there is a specific Bootstrap confidence interval app for a single mean and a single proportion. And we're going to use the Mustang price, the Ford Mustang data set. We're going to view the original sample. So this is a Bootstrap app. So they're going to use one sample and then create 2,000 resamples from the original sample. Okay, and we're going to look for our sample statistic and our estimate, and we're going to find our the estimate for our standard error. Okay, so let me go over to the applet. And you should have the link to this right above the video or in the notes or in our list of all the applets that we're using by module. So let me show you. I'm going to go back to Stat Key just to show you where these are. We were using the sampling distributions, this kind of middle row. There's a mean and proportion. Now we're in this middle column, Bootstrap confidence intervals. So we'll be doing means and proportions, but notice you can also do difference in means, difference in proportions, and also slope and correlation. So you might do those in a later class. Okay, so right now we're looking at a mean because we have a quantitative variable, which is Mustang price. So talking about the cars, not the horses. And I'm going to show you the data table just so you can see what it looks like. 32, 45, 11.9. Okay, wait a minute. These can't be just dollars, right? I wish. So these must be in thousands of dollars, and I did verify that with the authors of this data set. So these are, say this one is $14.9 thousand, so $14,900. Okay, so we will add that in to our work. And on this applet, it looks very similar to the sampling distribution one, but in the upper right small graph, you can see instead of the population, it has the one sample. Okay, so let's see, where's our population again? Oh, right, we don't have the population. I was trying to compare, but yeah, I'm still thinking sampling distribution. Our sample size, our one sample, has a sample size of n equals 25, okay? And the mean of that is $15.98 thousand. Okay, so that's our original sample. It's like the original 8 people in the picture I had in the notes. Now let's do one Bootstrap sample. Let's go back to doing a few of these so I can show you how it works. And you do have the option of choosing mean, median, or standard deviation. We're just going to do the mean. So if I hit generate one sample, that is a resample from the original sample. It's like when I shuffled the 8 people around. And you can see this 8.2 got chosen a lot. There's there's one Mustang in our sample with 8.2 thousand, and that one got selected quite a bit. So the shape is a little bit different. And let's go up the 45,000. This is the most expensive one in our sample, 45,000. That did get chosen, okay? And then here's the mean of our one Bootstrap sample, 14.9 $1,000. You can see how that compares to the original sample. It's a little bit less. But we are going to do repeated bootstrap samples, right? Because we want to get the idea of sample to sample variation. So let me do another one. And you can see our original one stays the same. Now this one is different again, right? We didn't get the 45,000. We got 32,500. Yeah, we got that one twice. And we got some more of the lower ones. So that one came out a little bit lower. And the arrow down here, that's going to be the average of the averages of all of our samples. Okay, so let's do another one. I'll just do a few so you can see how the resamples vary. So think of bootstrap sample or resamples, meaning the same thing, two different ways of saying the same thing. These are our resampling with replacement, meaning each car can be selected again. Okay, so you can see we are getting a lot of variation in our resamples. I'm going to go up to 20. Okay, now what would you guess the shape of this is going to be if I start going by hundreds or even tens? Go by tens if you want. I'm going to go by hundreds. What would you guess our shape is going to be? Okay, I'm up to 1,000. I'm just going to go for another 1,000. Okay, we still get this bell-shaped curve, don't we? This bell-shaped dot plot or distribution. Symmetric, unimodal. Of course, we have some variation, some jaggedness. And we have a standard error. Oh, that's our mean, sorry. Our standard error is 2.123 thousandths of dollars, okay? And then our original sample had a mean of 15.98 thousandths of dollars. So those are the numbers we're going to use for our confidence interval, okay? Now remember, it's a simulation, so if I did this again, I would get a slightly different answer, right? So I'm going to write this down on my paper. Actually, I'm going to write it down before I turn away because I won't be able to remember it. So the mean is, I'm looking at our original sample mean, that's our X bar. And I'll show you in just a second. 15.98 thousandths. $1,000. And then we want our standard error from our bootstrap distribution. So I'm going to write SE is 2.123 thousand dollars. Okay, so here I am back at the notes. Our X bar was $15.98 thousand, and of course I could write that out with the zeros, right? I could write 15,980, and that would be $15,980. And I could do the same with the standard error, $2,123. Okay, so either way works. Okay, so then in the notes, I put a screenshot of what we just did to show you. But because I just redid the simulation, we got a slightly different answer. But let's compare how it turned out. So our original X bar, that won't change, right? Because this original sample will come up every time you open up this applet and choose this data set. So we're only using a single sample in this app. It's not like we could try it with a different sample. So this stays the same every time, okay? It is helpful because when we're doing homework questions, we will get similar answers because we're using the same X bar each time. So this is our X bar. Now what will vary each time is our bootstrap distribution. Okay, so my standard error that I got last time was 2.161 thousandths. And we just got 2.123 thousand. So you can see there's a bit of a difference right there, okay? So when you're doing these homework problems, that's all coded into the system. That's expected. Or if I'm grading it, that's expected. That's why you show your work. In this case, you'll be showing your standard error and maybe even attaching a screenshot. Okay, so now that we have, let me just double check we finished part A. Find the sample statistic and the estimated standard error from the Bootstrap distribution. Okay, so we did that, and then here's the note. If we do this again, we will get a different result. Okay, so you know what to do from here because we've been doing it many times using our formula. Calculate the 95% Bootstrap confidence interval for the mean price of Ford Mustangs using the standard error. And of course we want to add our units in here. Okay, so I'm going to write, we don't have the margin of error. We're using 2 times the standard error for our 95%, 2 times standard error. So I'm going to write, and we have an X bar here. So I'm going to write the formula X bar plus or minus 2 standard errors. And you could use the decimals or the dollars. I think I'm just going to stick with the decimals because that's the way it was given to us, but it really doesn't matter to me if you want to do it. And especially it's not really writing any more digits. It's not millions or billions or anything like that. So it's not very much difference in the amount of writing. So we have 15.98 plus or minus 2, and I'm going to use the parentheses for multiplication, 2 times 2.123. Okay. Now I need to get my calculator. I'm going to do the margin of error first. So the 2 times 2.123 is 4.246 thousandths. If it helps, you can write it on each step or you can write it at the end. Okay, and then just like before, we go ahead and do our subtraction and our addition. $15.98 minus 4.246 is 11.734. Up to 15.98 thousand plus 4.246, 20.226. And that's in thousands. Thousands of dollars. So, or you could write it in 11,734, which I think does help people understand what we're doing if you make it more concrete. So that's $11,734 to $20,226. Okay, so remember we're estimating the mean price of Ford Mustangs, Ford Mustang cars that are for sale these days. The mean price is between, we're 95% confident that the mean price is in this interval, 11, that this interval captures the true mean of the Mustang sales prices. Okay? Okay, so very similar to what we've been doing, but the difference is how we get our standard error. Before we were using the sampling distribution, but in real life we don't have that. We just have our one sample. So we use our one sample to resample around 2,000 times. Then we get our new standard error. Okay? Okay, well let's do, let's see. Actually, I'll just keep going. Never mind. We're going to switch gears in the next video, so I'll see you in the next video.